Our sun, a brilliant star we often take for granted, is currently enjoying its middle age. It's a cosmic adult, shining brightly and steadily. The sun has been around for about 4.6 billion years, and it's expected to continue shining for another 5 billion years. That's a pretty long life, even for a star. But like all stars, our sun is not immortal. It's a giant ball of hot gas, mostly hydrogen and helium. Deep within its core, a powerful process called nuclear fusion is taking place. Imagine countless tiny explosions happening every second, fusing hydrogen atoms into helium and releasing an incredible amount of energy. This energy is what powers the sun and bathes our planet in light and warmth. The sun's core is a nuclear fusion reactor, a furnace operating at unimaginable temperatures and pressures. Think of it like this: millions of hydrogen atoms are constantly colliding with each other at incredibly high speeds. These collisions are so powerful that they overcome the natural repulsion between the atom's nuclei. When the nuclei fuse, a tiny amount of their mass is converted into a tremendous amount of energy. This energy, in the form of light and heat, then slowly makes its way from the core to the sun's surface, a journey that can take thousands of years. It's this energy that allows life to flourish on Earth. While the sun seems eternally radiant, the hydrogen fuel that powers its core is finite. Like a car running low on gas, the sun will eventually exhaust its primary fuel source. This won't happen overnight, of course. It's a gradual process that will unfold over billions of years. As the sun ages, the balance within its core will begin to shift. The outward pressure from nuclear fusion will slowly decrease as hydrogen becomes scarce. Gravity, always present, will start to gain the upper hand. This delicate balance between energy production and gravity is what dictates the life cycle of stars, including our own. In about 5 billion years, the sun will reach a critical turning point. With its core mostly depleted of hydrogen, the outward pressure of fusion will diminish, allowing gravity to compress the core further. This compression will cause the core to heat up even more, triggering the fusion of helium into heavier elements. The sun will begin to expand dramatically, transforming into a red giant star. As a red giant, the sun's outer layers will extend far beyond their current reach, engulfing the orbits of Mercury and Venus. The Earth's fate during this phase is less certain but no less dramatic. We'll explore that in more detail in the next section. Mercury and Venus, consumed by the expanding sun. The inner planets of our solar system, Mercury and Venus, will face a fiery demise as the sun expands into a red giant. Their close proximity to the sun will make them the first victims of the sun's growing appetite. Imagine Mercury, a small, rocky world, slowly being scorched and then ultimately vaporized by the intense heat. Venus, with its thick, toxic atmosphere, will fare no better. Its surface, already a scorching inferno, will reach unimaginable temperatures as the sun's outer layers close in. Both planets will be consumed by the expanding stellar inferno, their matter absorbed into the sun's outer layers. A celestial masterpiece. While the inner solar system faces a fiery fate, the sun's outer layers will continue to expand outward, creating a breathtaking cosmic spectacle known as a planetary nebula. These glowing shells of gas and dust illuminated by the dying star at their center are among the most beautiful objects in the universe. The planetary nebula phase is relatively brief, lasting only a few tens of thousands of years. During this time, the sun's outer layers will be expelled into space, creating intricate patterns and structures as they interact with the interstellar medium. These glowing clouds of gas will eventually disperse, enriching the surrounding space with the building blocks of future stars and planets. Section 8. White dwarf, the sun's cooling ember. As the sun sheds its outer layers, its core will be left exposed, a dense, hot object known as a white dwarf. A white dwarf is the remnant of a star's core, composed mostly of carbon and oxygen. Imagine compressing the entire mass of the sun into an object the size of Earth. That's how dense a white dwarf is. White dwarfs no longer produce energy through nuclear fusion. Instead, they slowly radiate away their stored heat over billions of years. As they cool, they fade in brightness, eventually becoming too faint to be seen. Black dwarf, fading into the cosmic dark. The final stage in the sun's evolution is the black dwarf stage. This is the theoretical endpoint of stellar evolution for stars like our sun, a state where the white dwarf has cooled down completely and no longer emits any significant heat or light. Imagine a cold, dark object, roughly the mass of the sun but only the size of Earth, drifting through the vastness of space. Because the universe is relatively young, no black dwarfs are thought to exist yet. It takes an incredibly long time for a white dwarf to cool down completely, much longer than the current age of the universe. So, while black dwarfs remain theoretical objects, they represent the ultimate fate of many stars, including our own sun. Section 10. Stellar Afterlife, the Sun's Legacy. While the Sun's journey from middle-aged star to black dwarf might seem like a story of decline and demise, it's also a story of transformation and renewal. The death of a star, while marking the end of one chapter, also heralds the beginning of another. The material expelled by the Sun during its red giant and planetary nebula phases will eventually mingle with the interstellar medium, enriching it with heavy elements. These elements, forged in the heart of a star, will eventually become part of new stars, planets, and even life. A cosmic perspective on life. The Sun's life cycle, from its vibrant youth to its eventual fade into a black dwarf, reminds us of the constant cycle of birth, growth, death, and renewal that permeates the cosmos. It's a story that unfolds over billions of years, a timescale that dwarfs our own fleeting existence. Yet, understanding this cosmic narrative, our place within it, can provide us with a sense of perspective and wonder. We are all connected to the cosmos, forged from the same stardust that makes up the stars. As we ponder the fate of our own star, we gain a deeper appreciation for the beauty, grandeur, and interconnectedness of the universe we inhabit.